Hello, my name is Omar Abdikarim, and I will be discussing with you one of the most technically challenging projects that I've ever faced so far. And this project was actually my bachelor project, and it falls under the umbrella of virtual reality. That's why it was so challenging. It was like a new technology to me, so I had absolutely no idea about any of the topics or like the subtopics in this project when I started. So first, let me give you an outline of this presentation. First, I'm gonna discuss what the research problem is, the previous work and what are the required added features that I wanted to add back then, the implementation details and the challenging parts, and finally the conclusion. First, the research problem was like to try, before I say what the research problem is, like I was supposed to use Unity, the Unity engine for that, for the sake of learning, and along with C Sharp, where both I haven't been exposed to before. And yes, I was supposed like to integrate the Kinect sensor, the one on the right, and the virtual reality headset HTC Vive into Unity engine and try to simulate a new communication method and test whether this method is going to be efficient or not. The purpose of this was like to have the sensor scan the full body of the person, have the person wear that headset. This another person would do the same thing, and they can communicate with their movements or with their sound through a virtual reality environment. Now, the first step I did when I was researching how to start, first I learned how to use Unity. Learning C Sharp was not that challenging, to be honest, because like my background was in Java, and they are both like under the same paradigm, so it was not that difficult. The difficult part was to extract the previous researches done in that topic. Now, most of the researches were done in the area of visual communication using just the Kinect, like to have two people communicate using the Kinect, just like an Xbox. Now, my purpose was to enhance this experience using the virtual reality headsets and testing and its applicability through a simple interactive game just when I finished. So the whole purpose was to implement this and have it tested by like sample subjects and then share the results. To test the hypothesis of whether this method is going to be efficient or not. Now, first, let me discuss a couple of things with you. Now, the interaction I had first to explore how the interaction between Unity and the Kinect is. There was a simple tool called Kinect Studio, which actually it extracts the body of the person walking in front of the Kinect. The Kinect has a built-in package which can detect the body, of course. And then there was a script inside, there was a package in Unity that I used to extract the user mesh, the user body out of the scanned environment. And then there is the generated mesh. Mesh is the term for the object getting animated in Unity. So all of these data were transferred through the Kinect Studio tool, and then the user visualizer script just extracts the body out of it, and it demonstrates this body in a 3D matter. So that was the first step of the project, is how this script is written and how to modify the script to be applicable to our use case. Now, the most challenging part, the most technically challenging part was the next one. Learning Unity and C Sharp was not that challenging, but the most challenging part was actually to have this animated mesh object or animated object to be transferred immediately on the network, because obviously you want the communication to be to have no lag whatsoever. So that was the most challenging part in this project. First, there was this package called Mirror. This package was very friendly to someone who just started using Unity. You just had to drag and drop the object, and That's it. The object is getting synchronized across the network. But what was different here is that Mirror was scripted in a way so that it can synchronize the movements of objects, like simple rectangles or simple squares or simple spherical objects, like predefined objects. So you just have to send over the network just the orientation and the position of the object at this time frame, which was not the case with the generated mesh from the Connect, of course, because the generated mesh had many more dimensions to it. It was very dynamic. So not just the position is changing, but the object itself is shifting in shape. So you have someone raising their hand, or any simple movement can how the user visualizer script extracts it is that it creates a whole new object and it destroys the old one. So to have this kind of dynamic motion be transferred in the network, it was very, very challenging. Now, the final solution was as follows. How I thought about this problem is that okay, so simple objects are very simple on this package because they are already predefined, and all we want to do is to just transfer the updates on the other side of the network. Because when it comes to Mirror, one side acts as the server and the client at the same time, and another side acts as a client. So what I had to do here was the diagram on the left explains how Mirror works in general, and then the diagram on the right gives what I did as a solution. So what I had to do is to re-implement or modify in the package, or the Mirror package, which is responsible for the networking, to have something customized for the user mesh extracted from the Connect, which I had done from scratch. So what I first had to do was to define the object for the script. It had to be defined in a way so that for example, the hands, the body, and the legs, and so on. So the purpose of this was to exactly implement what has been implemented in the package, but for a customized object. So I defined the body separately, the body, the arms, and the legs, and the head, and the orientation as well. And then serialize the updates in the motion of the body, just check what the difference is between the body position or the extract object, the exact object in the last time frame and this time frame. So for example, if you move the right hand up, you don't have to express it as the whole body has changed and then there is another one with the right hand up. You just have to give it that the right hand shifted up. That's it. So that was the solution, and it was not solved right away because still the amount of data and had to be serialized in order to be transferred in the network. So the server object or the server had to serialize the body of its own Connect, and then compress this data and then send it to the receiver, and the receiver does the exact same thing and send it to the sender. So yes, it was something like this. Of course, there were still limitations and some lags in the network, but it was acceptable. The shape here is inadjustable because the texture was another problem in its own, because the texture is a huge amount of data. But eventually we were able to reach, I was able to reach something that's acceptable and at least testable. So that was very good. And then I had to come up with a design for a game that tests my hypothesis. So the boxes in front of this person, he just has to point at one of them, and then we just calculate how much people correctly interacted with each other. And that was the results, and it seemed very good in terms of numbers. Of course, this is not the most accurate experience, but it demonstrated that it can be done. There were some limitations on the network and so on, but eventually it was thankfully done.